Let's do this problem right here. The question is asking find the eigenvalues of A. So let's see how we can do this. So first of all, in this kind of question, we take this equation right here. It's A x is equal to lambda x, and this is the general equation we use in all kind of eigenvalue equation, most kind of eigenequations. So in this case, what I have to do is uh, I have to bring it in the bring the like rearrange this equation to solve for lambda. That's what they are asking for, eigenvalues, right? That means the values of lambda. So in this case, if I rearrange this one, I have to bring this one, so it's going to be lambda I, because this is multiplied by identity, because this is, we are subtracting from a matrix. We can't directly subtract a number, so we have to multiply this by identity. Then it's going to be x here, that's equal to 0. So what we have to do is we have to set the determinant of this one equal to 0, and when we solve it, we will find the lambda. So that's how generally we find eigenvalues. So first of all, let's see what we get. So a minus lambda I, is equal to, so determinant of a minus lambda is equal to 0. If I set this one equal to 0, then so we are taking this one, right? So if I take that one, let's see what happens. So determinant, so you know, for 3 by 3 matrices, the identity is going to be something like this. It's going to be 1 0 0 0 1 0 0 0 1. So if you multiply with this one with lambda, what's going to happen? If you think about this is the only value is going to multiply, right? It's going to be this this one is going to be lambda, this one is going to be lambda, this one is going to be lambda too. So in this case, so when I subtract this a lambda, this is lambda I multiplication. So if I subtract this from a, what's going to happen is this is the only value is going to be get subtracted. This is 2 minus lambda, 2 minus lambda, 2 minus lambda, because others are going to be subtracting 0. That doesn't change anything. So in this case, I write this one right here. So it's going to be 2 minus lambda, 1 0 1, 2 minus lambda, 1, and the last one is going to be 0 1, 2 minus lambda. So now we have to find the determinant. So to find the determinant, usually the method we use is cofactor method. This is like we set this plus minus plus, and we keep going as it goes. So in this case, plus minus plus. So if I take this one, so let's say I take this 2 minus lambda. If I take the 2 minus lambda, that's positive. So I have to eliminate all the vertical and horizontal component of this one and find the AD minus BC inside. So AD minus BC is basically multiplication of these two. So 2 minus lambda times 2 minus lambda, or you can say 2 minus lambda square, AD minus BC. So BC is going to be simply 1 times 1, so it's going to be just 1. Then I have to take the 1 right here. It's minus 1 because it's minus on top. So minus 1, then if I take this one, I have to eliminate all the vertical and horizontal. This is going to be 2 0 1 2 minus lambda. So 2 times 2 minus 1 lambda is going to be or you can write it as 2 times 2 minus lambda, and other side you will get 0 times 1, and it's going to be 0. And the last one you don't even have to worry about it, because if it, for example, if you take 0 and find the AD minus BC and multiply 0, it's just going to be 0. So we don't have to worry about that one right now. So let's do this one right here. So if I multiply, let's see what we get. So this is going to be 2 minus lambda, and if you multiply and solve the other one, what you get is lambda square minus 4 lambda plus 4 minus 1 minus 1, and this is going to be 2 minus lambda, wait a minute, 2 minus lambda. So here we get 2 minus lambda, and the other side is going to be lambda square minus 4 lambda. 4 minus 1 is going to be 2, so it's going to be plus 2. But this is not a factorable form, so we have to use the quadratic formula for this one. So it's going to be lambda is equal to 4, so plus or minus b, so it's going to be 4 minus b, so it's going to be minus minus 4 is plus 4, plus or minus square root of b square minus 4ac. So b square is basically minus 4 square, it's going to be 16. 16 minus 4ac, so 4 times 2 times 1 is going to be 4 times 2. Then in the bottom we will get, so 4, so b minus b plus or minus b square minus 4ac by 2a, so 2 times 1, so it's going to be just 2. And if you calculate this value, you will get 4 plus minus root 8 over 2, and if you calculate this one, it's going to be 2 plus or minus root 2. Therefore we can say, so one of the answers is going to be lambda is equal to 2. This one, if you solve for this one right here, this is going to be lambda is equal to 2. So we can say, let's write it as lambda 1, lambda 2, lambda 3. So lambda 1 is going to be 2, and if I calculate lambda 2, so one of them are going to be 2 minus root 2, and one of them are going to be 2 plus root 2. So two values are possible, and 2 minus root 2, then lambda 3 is equal to 2 plus root 2. So these are the eigenvalues for this question, and that's how we do this question. And if you want to make sure whether we got the right answers, what you have to do is you simply multiply these three values, and also if you find the determinant of this one, both should be equal, because determinant of this whole thing and multiplication of these three should be equal. That's how we check this answer. And that's it. I hope you guys like this video. See you next time.